Everyone, we're going to take a look at number 1 in section 3.1. In the problem, we are given, as you can see here, the graph of a function f, and we're to determine f prime of a, that is the derivative, right, of the function at a, for a equal 2.5, 4, and 7. So remember, the derivative tells us the slope of the graph at a point on the graph. The slope meaning the slope of the line that is tangent to the graph at that point. And so let's start with 2.5. So at 2.5, notice the graph on the interval from 0 to 3 is constant. It's a horizontal line. And so anytime we have a line, right, we know automatically what the slope is. It's just the slope of that line. For horizontal lines, the slope is 0. So the tangent line in this case would coincide with this horizontal line, and therefore the slope at 2.5 is going to be 0. In fact, the slope anywhere between 0 and 3, anywhere between 0 and 3 would be 0. At 4, what's happening at 4? Notice the graph has a line that is not horizontal. And so the slope of this line is what? Well, looking at this line, I can see starting at 3,1, it goes up to 5,2. So I can sort of see what's happening, that the line segment goes up 1 unit, has a vertical change of +1, and then a horizontal change of what? 2 units. So the slope of this line, the rise over the run, or the vertical change over the horizontal change, is a +1 because we're going up 1. That's the vertical change divided by the horizontal change, or the run, of 2. So I get 1 divided by 2, or 1/2. So that means for any value between 3 and 5, the derivative of this function would be equal to 1/2, because that's the slope of the graph. And then at 7, notice between 5 and 9, the graph is not a line anymore. It's not linear. It looks like a quadratic function of some type, possibly, right? And the slope is changing. The tangent line changes as x varies from 5 to 9. Between 5 and 7, if I check any point on the graph of the function, the tangent line will be a line with positive slope. And as we vary from 5 to 7, that value of that slope, the value of the derivative, is going down, right? So close to 5, between 5 and 6, close to 5, the slope is fairly steep. So the slope is a big number. And as we move closer to 6, the slope is getting smaller. Okay. After 7, notice the function's decreasing. So at any point, the tangent line would be decreasing, meaning the slope is negative. And notice it gets more negative as we vary from 7 to 9. But right at 7, what would the tangent line be? Well, the tangent line would be a horizontal line, the line that just touches the graph at the peak, right, of that graph. And again, a horizontal line has a slope of 0. And so that is the derivative of the function at 7. So as we vary from 5 to 9, the slope goes from a negative value to 0 at 7, sorry, a positive value to 0 at 7, and then to a negative value as we move across there. That's what happens to the derivative. Now, they don't ask 2 important points here. I think I just want to mention before I submit and check my answer, is the derivative at 3 and at 5. Notice at 3 and 5, there's a sharp turning point. So at those points, we know the derivative does not exist. As we're approaching 3 from the left, the derivative from the left is 0, right? Because any value between 0 and 3, the derivative is 0. But between 3 and 5, the derivative is 1/2. And so we're approaching the derivative from the right is 1/2. The derivative from the left is 0. And so we have an abrupt change. And so the slope is undefined right at that point 3. Same goes for the point at 5. Okay, so let's check our answer, make sure I'm doing this correctly. Hey, okay. So again, hope this is helpful. If you have questions, as always, let me know.